Signori, buonasera, benvenuti. Welcome to Linea Pelle. I am Loreto di Rienzo, Technology Ambassador of the D-House by DYLOAN. D-House by DYLOAN is one urban laboratory in Milano. It's born 2 years ago from the factory, Bone Factory. And we have experience about the application of the technology. Today, in the house, we have a different partner. I involve in the project of the house different partner. STRATASYS, 3D print, FRAMIS is thermo-welded, Coloril is embroidery, Universal Robot. And we involve the material partner, for example, Linea Pelle, for example, Woolmark company. And the focus is R&D, research and development, is evolve the technologies, and is the sustainability. We work up the different type of project because we are one manufacturing. And when we speak about the technology, it's very important. We think about all process, from the idea to the organize the project, the sample and production. This is very important. Follow all procedure, all process. Today we want to indicate. We want to try to understand with the partner what we involved, how the technology is possible help for the customization. Customization is the one process very important in the sustainable approach, because technology help for apply up the garment or the accessory in the end of the process. And this permitted personalize. Allora, today I want to introduce the FRAMIS Italia. Andrea Rebonato is marketing and product development, nozzle bonding technology, and the responsible way to customize and revamp shoes and garment. STRATASYS, Enrico Toson, Regional Marketing Manager 3D Print Technology, to enable the customization of material of product. And Universal Robot, Paolo Bassetti, Technical Support Engineering, the use of collaborative robot in fashion. I want to first give the microphone to Andrea Rebonato.
I'll take off the mask. Okay, thank you, Loreto. Thanks also to Linea Pelle for inviting us at this event to present you what the nozzle bonding technology can do for help brands and designers to customize and to make a responsible approach to garments, or to revamp and to customize all these things. Basically, everything started more than 40 years ago. During the 80s, it was the first experimentation with the bonding technology. What is the bonding technologies? Is a solution that helps you to customize, embellish, or even manufacture a garment or a bag or an accessory, a shoe, without using any stitching at all. It works basically using a adhesive, so a chemical component, and on the other side, using a technology, a heat press or a thermo welding machine, in order to be able to apply and to use this adhesive with the material. In the 80s, it had mainly a functional reason. It was used to restore the waterproofness on garments, on boots, on tent, on technical or outdoor gears. But now it has become more and more familiar or usual in many other applications. In this context, FRAMIS has always been playing a fundamental role with this NOSO technology. NOSO is one of the brands of our company. And basically, as I was explaining to you before, there are two sides in using the bonding technology. One side is the chemical part, the film, the tape, the part that needs to be applied on the garment. On the other, there is the machine or the technology. We are the only company worldwide able to offer a solution that is integrated. We have one division that is working on the consumable part, so film, tapes, etc., and another division that is working on the engineering part, so machine, heat press, etc. The two things together makes a unique system that is able really to satisfy the needs of the customer and to be able to be very close to his goal or his target. One part I was explaining to you is made with thermal welding films and tapes, and basically you can use it or them to decorate a garment or accessory or a shoe, or you can use it to manufacture it, so you don't use stitching but you bond together the fabric in order to achieve a construction without any stitching, any hole, any thread. On the other side, we have the machine. So the way to industrialize and to make in continuous this process that was born, or it is very common on a flat and very on a shape, so on a flat surface. But with the machine, you are able to have a more continuous and more industrial way to approach this technology. What you can do with this the combination of the film tapes on one side and the applicative technology on the other. You have mainly three areas where you can work or you can use the technology. On one side, you have the decorative part. You can use it to tape, to embellish, to create label, to apply label, to put customized shapes on garments, etc. The second part is more functional. When the technology was born 40 years ago, it was mainly for restoring the seam sealing on garments. Now it has other functional aspects such as reinforcement, compression, waterproofing, etc. that helps the garments or the shoe or the accessory to become more functional. And third, there is the structural. It means building and manufacturing the garments or the shoe or the accessory or any apparel things without using any stitching. From the 80s to now, the technology has evolved a lot, and now is helping, and we are helping a lot of designer brands and companies to develop solutions that are very innovative and also creative. So besides being able to substitute the stitching, we can also add something that you can achieve with other technology in terms of decoration, in terms of construction, in terms of combination of the two, in terms of opportunity and possibility for the designer. One thing that is even more important for us is also to be able to go down along the supply chain and be able to offer a solution that is even more close to the needs of the customer. Once what we produced was mainly a film or a tape that was available in many colors that could be used in many applications, but now we are able to offer something that is much closer in terms of decoration, embellishment, labeling, logo, etc. These are some examples that has been used from some of our customers to decorate their garments. One aspect that it is maybe common to some of you is that to use a thermal welding product, you need a flat surface and a heat press to transfer to make the glue or the adhesive to melt down and to be applied and to bond to the garment or to the fabric. The challenging for us was now to be able to work not only on a flat surface or with a common taping solution, but to be able to work also with a 3D part. For example, a finished garment, a finished shoes, or an accessory that is already built and maybe is there and needs just to be customized. So the goal was to be able to take a piece of garment, in this case a denim jacket, and decorate it without using any stitching and in any case, using and following the shape of the garment. So we are able to work along the sleeve, under the armpits, in many parts that are not only and exclusively flat surfaces. This was a very challenging point for us, and thanks to a series of innovation, a collaboration also with the house, we are here presenting you some solution to work on a 3D garments and shoes using our decorative solutions. At the end, what you will see when you move there, but I have here some pictures, is that you can work on any kind of t-shirt, jacket solution that needs that is not flat, but needs to be followed in certain shapes in order to not affect the design of the garments or the performance or its aspect. In this situation, we are taping with one of our tape one sweater, and the solution you can see there is very nice, is very beautiful, and you're able to follow all the shapes and all the details of the garments, something that you can't do or you couldn't do until a few years ago with the usual thermowelding technology, but also with our other decorative solution is not so easy to do, or it's not possible to do. Even shoes, we decided to do something or try to find a solution to customize it as it is. When I say as it is, it means with the shape of a normal shoe. So you're not working with open shoes before finishing it, but you are working on a shoes that you can have there at the end of your sales season, some that stocks there. You can take your shoes and you can revamp them using the technology. It's something that you can, is very difficult to do with other solutions. And most important, we wanted to develop a solution that could be industrialized. I mean that it can be can be done in continuous without having a moment where you have to change all the technology or with a very slow production time. But at the end, what are the advantages that I try to explain to you, and now I try to recap in this slide. First of all, using the thermowelding technology and our nozzle technologies, you can work on garment without any need to separate part, unstitch it, or to open it when it's already manufactured. So you can take anything from your warehouse or anywhere, or even something that is supposed to be produced for a or customized for a final consumer, and customized directly as it is. Second point is that we are working on a surface. We don't affect in any way the fabric. We don't put any thread. We don't need any hole with a needle. We are just applying on top a solution or a thermoadhesive that bond on the fabric without affecting it. And for certain technical things is very important because you are maintaining the performance in terms of waterproofness, etc. And third, you can work on a 3D solution. The machine has been developed to work and to follow the shapes of the garments, of the shoe, of the bag, etc. It's something that it was very challenging, but we are able and very happy and proud to solve or to offer as a solution. Why do we define this solution as responsible? Mainly for the reason you see here. First of all, following the shape of the garment, going directly with a machine that is following the maybe taping or doing other things directly on the garment, you have basically no waste of material. You are putting exactly where you want it, your material, your decorative tape, your shape, etc., without any waste during the construction or the decoration of the garment. At the same time, we are able to offer to our customers a solution to revamp or to not throw away their dead stock at the end of the sales season. Imagine that something was not as expected in terms of sales of a certain jacket or a certain garment. Using our solution, you can take them, upgrade them with some solution, put some embellishment, make them more up to date to the current trend, and put again in the shops. At the same time, you can, and the fourth was that this solution can also be seen as a solution to be even closer to the needs of the final consumer. We know that now the brands are more and more, I can say, they pay more and more attention to the needs of their customers. They want to offer a solution that is really very close to their needs in terms of personalization, name, letter, logos, colors, etc. In this case, you can be able to achieve this goal starting or having a standard product in your warehouse or available and working piece by piece using the technology you saw before. So basically, we believe that with this solution, you have a very responsible way to approach this market or this situation, but at the same time, also a solution that is even more closer to the needs of the customers in terms of final consumer, in terms of approach or customization to them. And therefore, we are pretty satisfied with the solution that we are able to offer. And now, that's it.
Thank you very much, Andrea. It's very important because customization is possible apply up to three really type of product. The new product, the vintage used, or it's possible apply everybody know where is the big problem of the storage, where is the not seller pieces. And technology is the instrument what help for resolve this type of problem. Now I introduce the second partner is Enrico Toson, STRATASYS Regional Marketing Manager 3D Print Technology to enable the customization of material and product.
On, yes, okay. So good afternoon also from my side and from STRATASYS. And thank you, DYLOAN, and thank you, Linea Pelle, for allowing us to talk about 3D printing. So first of all, just a quick intro. Who is STRATASYS? STRATASYS has been basically a company who was founded in 1989 and is the company who actually created one of the most widely used technology in 3D printing. So I think, it is a synonym of 3D printing. And today we want to explain you, we want to show you what we've been working on for the last few years and actually together with DYLOAN in bringing 3D printing to fashion and 3D printing directly on fabric, okay? We think this is a great opportunity and the partnership with DYLOAN has been, allowing us to move it into, with the clear objective of moving into production and making a real production technology. Let me go. Okay, 2 words about 3D printing in fashion. Why is it interesting? I think number one, I really have 3 things that I would like to point out. Number one is sustainability. This is intrinsic to 3D printing and additive manufacturing. It is a sustainable technology in itself. Why? I mean, first of all, you only use the material that is needed. There is no waste, no scrap, so it's technology that is very lean, first of all. Second, it allows extremely high levels of customization and personalization. Why? There are no economies of scale, so when you 3D print, you can do, 100 products, the same or all of them different from one another, and it's the same. So it really allows you to customize anything you do when you 3D print. And last but not least is freedom of design. In fashion is all about innovation, is all about creativity. So we do believe that 3D printing really, and 3D fashion as we call it, allows a new level of creativity, for fashion designers. And I'll try, to show you some examples of the journey that we've been, doing over the last, actually we started in 2013 working with many different designers, and hopefully more and more will come and be working with us. Let me actually start from a video so you can take a look at what I mean with 3D fashion. right. So I hope that gave you an idea, a glimpse of what it can be done. Of course, all the things, the technology, the systems, and some printouts you can see here in the booth later on if you wish. But let me just start where it started. In 2013, we had maybe the first engagement with two designers, Aris van Herpen and Neri Oxman. Neri Oxman's works are actually at the MoMA in New York, and we started, working with them. As you can see at the beginning, it does not really look like a real dress. At the time, we were still not able to print directly on fabric, so it looks like actually we're in a sculpture, maybe not the most comfortable kind of garment. Still, in terms of creativity and design, I think it's quite compelling. Now, when we moved on, this is the first time in 2018 when we were able to print on fabric. It was transparent fabric, but you can see all the leaves, all the it looks like a sculpture, like a full dress. That was completely 3D printed. So it was the first time for us that we really had, for the first time we started printing on fabric, and that's where it all started. So we went on and we started, adding color. The technology allows you to really use as many colors as we have 600,000 that we can manage and print with the printers, and I mean we can do Pantone, for example, and here you see some examples. This is also a particular kind of all these kind of needles show the accuracy that the technology can achieve. We're talking about 1 millimeters wide and 3 centimeters high, kind of stitching out in the dress, allowing a pretty peculiar and unique kind of design. This is another one that was done with Greta Otto, with 3S4 and Travis Twitch, US designers, fashion designers. This again, I mean, it's a technology we call lenticular. So it allows basically to print each kind of pixel. Think every point can be seen with different colors depending on the angle that you look at. So it has an extremely interesting and changing kind of effect when you watch this kind of dress. This is again just to show you what the technology allows you to do. And again, it's all about creativity. It's all about unleashing fashion designers' creativity using 3D printing. And moving forward, again, just this is another one that we did with Julia Corner. This was kind of a urban design, so it was about printing and having projects that could be assembled directly when the garment was supposed to be used. So kind of a design project. Again, kind of interesting. And this is a denim capsule that shows you what we can do directly, again, for example, on denim, on jeans. The interesting part is that we can play, and we use what we call kind of techno materials, because with the 3D printer, you can simulate not only the colors, but pretty much any kind of textures or different, kind of materials. So you can simulate wood, you can simulate marble in any color, in kind of also in different what we call shores. So it can be soft or it can be hard, depending on what your aim is. You can do pretty much any way you like it, and you see the kind of effect that it can be achieved. Okay, this is another one. I think it's Genny Goldstein. This is a kind of a Japanese kimono. And here we've been mixing two different technologies. So it's 3D printing, but also traditional embroidery, which I think is kind of unique, because the objective was to see, or to show, that we can basically mix and match different technologies and use 3D printing, to achieve the same levels of artisanship and that you can have on more traditional technologies like embroidery. But I think it speaks pretty much on itself, and it's quite an interesting realization. This is a more traditional one. Sometimes we say they tell us, well, it's all about showing new things, kind of crazy disruptive things. This is also something that actually mimics more traditional kind of patterns. This is suede leather, and it achieves that basically the 3D printing technology can be used in pretty much any kind of you want basically. You can mix and match. You can be more open, traditional, or disruptive, whatever you feel that you want to achieve. This is, again, a project from last year. I think the team from DYLOAN will smile. It was done together, with them, DYLOAN, and okay. Loreto knows much better than myself. And this is, again, for me, it was quite amazing. Everybody was been, seeing this realization, was really amazed at the kind of mixing, actually, of, again, different fabrics, mixes, and the results, basically. This is another one, still, again, with DYLOAN and the Woolmark company, and you see what was achieved, kind of unique things that cannot really be made with any other, technology. And of course, I think it's a journey that we're starting, and the more fashion designers get to know the technology and how to use it, the more incredible things we will see coming out from from their hands and their minds. This is something that you can see here at the booth behind me. Some of the buttons because of course the technology can be used also, for example, in fashion accessories, or can be used for personalizing existing garments like this pair of jeans, and this is something also interesting about refreshing your wardrobe, for example. So it has a lot of different possibilities and opportunities, and that's part of the tiger. The tiger is also printed over there and visible at the show. Quite impressive, so stop by and take a look if you wish. This is how it looks like. Basically, it prints directly on fabric, as you can see. It comes out of the printer like that. Just to give you an idea. Again, the printer is printing live right now. So if you're interested, you can stop by and take a look yourself. Of course, we don't stop, to garments and fabric. Of course, that can be used, especially when we talk about leather. It can be used with shoes, of course, with bags, with fashion accessories. So there is a whole set of different opportunities that we can basically work with 3D fashion, out there. Now, let me quickly move towards the end and talk a little bit, at the underlying technology, just to give you a better understanding of what it is and how it works. Instead, of applications I already spoke, it's definitely about shoes, it's about garments, it's about bags. We have examples. We've seen incredible things already, actually developed by DYLOAN, but some of their customers, of DYLOAN customers. Of course, we cannot maybe mention some of them, but it has been already achieving some interesting results. You can print on ribbons. You can print on on just plain fabric. And you can, of course, work on just decorative or different things. And in terms of the kind of fabric that we support, we've been extensively working with cotton, with linen, with polyesters, and also with leathers, sweat leathers and normal leather. It depends. Usually, we do all sort of tests, but the technology is pretty, I would say, flexible in the type of materials that is able to, to print on. I think what is important, and I want to stress that, and this has been really the core of the partnership with DYLOAN, our objective as STRATASYS is to make the technology a production technology. So, I mean, we have 30 years, or more than 30 years of experience working with the leading companies in the world. We have parts of rockets in the space that, use parts printed with our technology. So we know what it means to be mission critical, what a production environment is. We want to work, with a partner like DYLOAN to make sure that we understand, the fashion industry and, how its production works, and make sure that our technology is, fully compliant and also, as fast as needed and as productive as needed. In terms of technology, it's really kind of an inkjet technology, the one that we've been using. So I think all of us are familiar with 2D, inkjet technology. It's just, little droplets that get shoot, towards a sheet of paper. Here, it's not a kind of a 2D kind of inklet or small drop. It is a 3D, drop, small, that we call the voxel, and then, drop by drop, basically, you're able to build your final design and what you've been seeing before. It, it makes different colors, transparencies, or transparent materials and support materials to achieve, what, some of the printouts that we've been seeing before. Just a quick note on, let me say, how it works really. The bonding between the resins and the underlying fabric is a mechanical one. Okay, so we don't do priming, we don't use chemicals. It's the ink or the resin that is liquid, and when it's solidified by UV light, it basically can go depending on the porosity of the fabric, can go through or or stay at different levels, and we can actually tune it depending on what the effect or the strength that we want to achieve. But it's a mechanical bonding, okay, between the resin, which actually produces the 3D printed part, and the underlying fabric. This is the machine. This has been, we call it right now, the 3D fashion printer. It will be officially announced in a couple of months' time. The technology has been running and used, by hundreds, if not thousands of customers out there since many years. But again, now we're bringing, all of its capacity into the fashion and into the, print on textile and print on fabric, kind of setup. We have, of course, all the, the underlying solutions to do, the interfacing with existing design systems like CAD, the software, and so on. I mentioned, the colors. I mentioned, Pantone, and this is also something, that we've been working on for many years now. Mentioned Pantone. This is what, the kind of cartridges and that basically allow you to, to print the basic colors, the transparent, the support, and the black and white, cartridges. Getting to the end, I mean, we're here on a journey, okay? So we have a clear roadmap already outlined by the business unit, and a set of capabilities that we're working on to bring more and more to the market. New capabilities, so we're testing and working with different fabrics and keep adding them. New type of resins, looking at sustainability, and new formats to being able to print on larger kind of set of fabrics. Increase productivity end to end, so it's not only the throughput of the machine itself, but how its repeatability and how it connects into the different manufacturing environments from a connectivity standpoint. That is expected by production. That from a production standpoint. In terms of usability, also make it much easier and faster. Calibrations, alignments, and really be able to use the machine in a digital workflow as easily as possible. And of course, we're also spending, or making a lot of effort in making it, compliant with the sustainability and certification standards that are out there. I think we're pretty well advanced. I think, we were well aware of, for example, what top brands are asking for, and we are compliant, I would say, almost 100%, and we keep improving. So I think it would be also, from that standpoint, you can rely on us. That's it. So I want to thank you. Again, I want to invite you, come to the booth and take a real look. Bye-bye.
Thank you, Enrico. It's very interesting how many solutions, how many possibilities the technology give for personalize and give value up the product. The last partner is Universal Robot with Paolo Bassetti. I want to really understand how it's possible with the robot customize. Please.
Yeah, thank you. Thank you, Loreto. Can I have the... Okay, so just to set the stage, a few words very quickly about Universal Robots, which is a Danish company born 15 years ago. And we basically produce this kind of robots, small robots, collaborative robots, and in 4 different models, ranging from 3 kilograms of payload up to 16 kilograms. Usually, we are used to see in television and so on, standard robots, the one you see on the left. And we are instead produces collaborative robots. What does it mean? It means that basically, according to the risk assessment, but basically the idea is that this kind of robot can be used together with the operator, without fences, without barriers, okay? And the key points of the cobots is that they are easy to program, they are very flexible, meaning that they can reach position very easily, and they also very flexible from an application point of view. And also, they are perfect for high mix, low volume kind of production. So when you have to produce very few elements, let's say very few pieces, and very different one to each other, okay? Typically, we have this, typically we use this robot to this kind of applications, so machine tending, or also screw driving, palletizing, dispensing, quick quality control, and whatever. So these are the usually applications that we use our robot for. But here, I want to introduce you to the use of this robot in the fashion world. This is an application we developed with the DYLOAN last year, in which the robot could pick from here, from this part, this kind of component. It was shapes made by leather, I think. And the robot, through the camera, could recognize the position and also the shape that he's supposed to pick, and so create a pattern, for example, like this, on a specific surface of a garment or whatever. In this case, was not applied a glue, but I can also decide to apply a droplet of glue to fix the robot, also because we have here in the robot flange a sensor, a force sensor, through which I can apply a given force, a specified force. Here is another interesting example in which my colleagues on the left was just teaching a sort of spraying application. Okay, for example, if you have to, spray some sand or something like that on a garment to produce that old-fashioned and used characteristics. So the idea is we just take the robot and move it by hand freely, and then the robot on the right repeat the same path, the same shape, and it can also memorize the moments in which the user had triggered the spray. Okay, so you can start and stop the spray according to what the user did. And with this kind of approach, we realized several applications in this kind of industries, because you can set up an application like this in 20 minutes, something like that. Okay, so very, very easily. Here is another interesting application by Atom Lab, in which they take this shoe sole. Actually, in this case, they were able to let the user select in a 3D environment which kind of sole they liked and which kind of shoe they liked. There were several colors, several shapes, and so on. So the robot will take the shoe that the customer choose, and assemble it. So it position the shoe the sole on the shoe, applying some glue with this machine, and so on, and then takes all the shoe complete and put it into the press machine in which it is pressed and heated. Now, in all these examples, what you see is that the robot is very, very easily programmable. So I can adapt what the robot is doing to the specific request of the operator, of the customer, actually. Meaning that in this case, for example, I can change by a computer, from a computer, according to the specific project, design, idea of the customer. I can change the shape that is produced, how many shapes, which size, and so on. And the robot can recognize where to pick this shape, both because the cutting machine tells to the robot where it is, or optionally, through the use of a camera. Like in this case, there is a camera on the ceiling that is looking at the table, and then the camera just says to the robot where to pick the part. Okay. Here we have another interesting example in which the robot loads this part of fabric, and there is a sewing machine that is fitted with the robot, as you can see. Again, here I can very easily change, for example, the path that I want to follow, the size of I suppose this is a sort of bag, because it sews 3 different sizes. And so I can choose what the robot is supposed to do. I can do a sewing smaller, bigger, longer, whatever, in real time. Okay, so it's not a machine that is running all the same time, all the time in the same way. I can just change when I like what it's doing. And here is my last example that you can see here in the booth near you. In this case, we just imported a CAD model of this body shape, and then they created the path of this garment. The idea is this. Okay, that on the left in red is the result. The idea is that here the robot is just following a path, and the path is given in a 3D virtual environment through the CAD. But basically, it can be adapted in several ways. I mean, in the future, we can also decide to scan the body of the real customer and then change the shape, the decoration, the pattern, the measures, the size of this printing path accordingly to the shape, let's say, of the body itself, so to the size of the body, okay? So, again, in this case, it's very, very flexible, very easily programmable, and according to the kind of software that you use, you can achieve results very different and very complex, more or less complex. But basically, in this case, the robot is just holding this printing machine, this printing head, okay? It's a 3D printing head. And with this, we can produce whatever application we want. So, for example, if you want to create a 3D printing not on a garment, not on a solid structure like this, but for example, like something like a pottery, a vase, okay, you can also do this, given that the material is able to sustain itself, okay? So the basic idea is that with this kind of robots, we can just program them to be extremely flexible and adapt to the specific customer needs. Thank you.
Thank you, Paolo. Very interesting the solution, this application. Have some question, because all this technology is in D-House, Laboratorio Urbano in Milano, and D-House help for the project and help for the production. In D-House, all partner is resident in D-House for help and evolving the technology in the direction of the customer, the client want. Okay, thank you very much, and it's possible go to see the exhibition just here. Thank you. Thank you.
Come on!